Recording is starting, so I will hand it off to Reggie and Manuel to introduce themselves. And gents, thanks again for presenting.
Thank you, thank you. Manuel, you want to go ahead and introduce yourself? After you do that, then I can start with my presentation because my introduction is inside my presentation.
All right, good deal. So, hey everybody, I'm Manuel Garrigo. I'm a cloud solution architect on the U.S. education team, and we super happy to have Reggie on our team now. Finally, took a while, but we got him. And I'm here to support Reggie. This is the Reggie show. So, thanks everybody.
Awesome, awesome. So what I'm gonna do, I'm gonna go ahead and kind of like share my screen, and then from there I have my presentation inside my introduction inside of there. So for the bandwidth purposes, I'm just gonna turn off my camera right quick, but man, we'll be on the back end looking in on a lot of things. So let me share my screen here. Should be seeing the screen in a minute. Let me know when
Yep,
you
we
see
got
that
it.
screen, please. Awesome,
We got it.
awesome, great, great, great. So I just tell you a little bit about myself here. I have a slide that I normally use here, so this kind of to give you the input output of my life. To be honest with you, my name is Reggie Snead. I have three kids. Might as well say grown adults at the moment. 23, 19, and 17. I am a senior cloud solution architect based out of Tampa, Florida. I just moved here probably like almost 8 years ago. I'm originally from Georgia, so you probably hear that little country slang a little bit. So the university I went to in Georgia was Middle Georgia State University, and also on the right hand side, you'll see that some of the companies that I have worked for that led me into this, I would say, Azure cloud business per se. But the biggest one that I started that led me here is University of South Florida. I used to work for University of South Florida and started a cloud first project. And now I was a Azure consultant coming in, then ended up being a cloud solution architect for professional services, and just moved to the EDU probably about a month ago. So, like Manuel said, glad to be here because my cloud journey started at university. So, it's glad to be on the EDU side. So what I'm gonna talk about, to be honest with you, is Azure Confidential Computing. Many of you guys probably never heard of it, but it's something that back in January through June, I was able to work with the on the PG side just to see how the sauce is made. Everything is up in the hood. And one thing they talked about that interests me was Azure Confidential Computing. And my whole thought was like, why more customers not using this service here? So I'm gonna run through a lot of the slides. I don't want to slide deck you to death. It probably only take an hour to get all this out, but I just want to know, at the end, what you think about it, what you think about the future of Azure Confidential Computing, because this is something that as Microsoft as a whole is looking for to change a lot of things with. So, as you see, we say one confidential Microsoft, right? So, everybody probably heard it take a village to raise a child, right? But right now, it take a village for us to get Azure Confidential Computing together because it's more than just one team. If you see here, you have the ACC team, which is the Azure Confidential Computing team, the Azure Core and Specialized Compute team, the Azure Core Security team, Azure Edge, and so on that you see here on this slide deck here. And the agenda today, if we want to put something to it, we'll do a background. We'll talk about a few of the customers that we're working with Azure Confidential Computing, and also we'll talk about confidential computing at Azure. On the next slide here, you will see just some kind of numbers that we kind of put out just to get everyone excited about what we're doing in SCI, which is the Azure Cloud Security. Some of the best in class things. So we try to make sure as a whole, as a Microsoft whole, that we are secured even in even like if you on-prem or you in Azure, we try to make sure that we secure in the money that we spend here. So more than 650,000 customers and 90 of the Fortune 100 trust Microsoft SCI solutions. And as you see here on the next, so Microsoft employs over 8,500 security experts and committed to 20 billion in security investment over the next 5 years. Since being here for 4 years, I have seen so many security experts that have started with Microsoft either on the EDU side, professional service, manufacturing, everywhere around Microsoft. They're hiring now security experts for Azure. So in 2020, 9 billion malware threats, were blocked on endpoints by Microsoft on own 365 Defender. That is a huge number, something that most people don't even know that we're doing in the background, don't know the threats that we catching in the background. But as a whole in 2020, it was like 9 billion malware. I'm sure in 2021, it's probably about 18 billion. Stuff keep on adding up because all the, I would say, bad hackers that's going on now in the world. And Microsoft processes over 24 trillion signals every 24 hours. So what makes this really huge to me, right, is that today customers want to fully trust Microsoft, right? They want to trust their hypervisor, they want to trust DevOps, they want to trust the agents in VM, they want to do networking and etc. Right? So most of these customers, they're looking for a way to trust as little as possible, even trusting themselves, to be honest with you. So they're a class that's willing to put customer data into the cloud, that would love to reduce their trust in CSPs, which is the cloud service providers, as much as possible. So customers are expecting many of these capabilities just straight out the box. If you look at the life cycle here, the full control over the data life cycle, you have the privacy at the top. Then you go from left to right. We're looking at untrusted collaboration, customer trust, and regulations and compliance. So our normal thing that we've been talking about, I'm not sure how many people have been in Azure, how long you've been in Azure, but one of the things that you see is data at rest and also data in transit. Your data at rest is like encrypt inactive data when stored in blob storage, database, and etc. Your data in transit are encrypt data that is flowing between untrusted public or private networks. Now what's going on with Azure confidential computing, we have the thing called data in use. So this protect encrypt data that is in use while in RAM and during computation. So it protects against malicious privileged admins or insiders. It protects against the hackers exploiting bugs in the hypervisor of the OS. And also it protects against third parties accessing data without customer consent. When you say third party, then you're talking about Microsoft as well, right? So this is going to protect anyone for accessing the data without customer consent. So,
hey, Reggie, just want to
yes.
double check on click on some use cases here, right? So a really good point. You're talking about third party, right? Your cloud provider, right? Insulating yourself from your own cloud provider is an interesting use case, right? I think that's clearly applicable. The other one that's interesting is many of our education customers collaborate with peer institutions. That might be other higher ed institutions. They could be academic medical centers with medical providers, et cetera. And so being able to ensure that that data is protected while in use can be very powerful for collaborative scenarios as well. That third party doesn't have to be a combative foreign party. It could be a collaborative foreign party.
Yes. Absolutely. Absolutely. So here, you just unsecure your sensitive and regulated data, right? While it's being processed in the cloud. So, like I said, we call it ACC for short. Everybody have they anonyms here. So it encrypts the data in memory and hardware-based trusted execution environment, and then it processes only after the cloud environment is verified, that helping prevent data access by cloud providers like Manuel was talking about, administrators and users. So you build on top of that secure hardware using like familiar tools, software, and cloud infrastructure, or you can migrate your existing workloads and application as well. And most people say, what is confidential computing? So the big thing about this, right? Like I was just saying, the protection of data in use, the protection of data in use that's never been there before. So I tell most people, we're not trying to, we evolving, right? So this is an evolution of our VM offerings now. So I get to some of the offerings that we do have now that's coming up, things that's in the works. It's a lot of things going on behind confidential computing. So it'll be great just to get in on it, look at it. The pricings are not that huge from a regular VM, but it'll be great just to start doing some testing environment in your Azure cloud now. So this is one of our visions, and I was kind of trying to hit on it at first, but I had to slow myself down. If you read here, we're trying to transform the Azure cloud to the Azure confidential cloud. So this enabling the industry to move from computing in clear to computing confidentially, both in the cloud and on the edge. I'm gonna let that sit there for like 2 seconds so you can read the vision of Microsoft Azure Cloud, that we're trying to transform this to the Azure Confidential Cloud, that everything you deploy in a VM, it'll be confidential. So that's what we're working on now. So when we get into the confidential cloud, right, when you look from left to right, the data is fully in control of the customer at rest, in transit, or in use. The code running in the cloud is protected and verified by the customer. And the cloud platform provider is outside the trusted compute base. And also the activity history is immutable and auditable. So I'm gonna go to the next slide. Many of you probably know him, many of you probably don't, but I want to play this next slide here. Hopefully this right here work for me. Here we go.
When we say the trusted computing platform for all organizations and all platforms, we mean it. Azure is the only cloud provider enabling highly regulated industries to bring their most sensitive applications to the cloud. Azure Confidential Computing can help you protect data while in use, thanks to enclaves that protect and isolate code and data in a zero trust environment so that customers can prevent even Azure as the cloud provider from gaining access. We provide the broadest and deepest set of virtual machines, containers, and services powered by the latest confidential capable CPUs from Intel and AMD, as well as confidential GPUs from NVIDIA. And we continue to expand our Azure Confidential Computing portfolio with confidential VM node pools on AKS, enabling a seamless lift and shift of Linux container workloads and confidential VM options on both Azure Virtual Desktop and SQL on Azure VMs. I'm also excited to announce the preview of Azure Managed Confidential Consortium Framework, which allows developers to build, deploy, and manage highly sensitive multi-party applications. Calstone, the largest global funds network, for example, is using the open source framework to confidentially share trading data across the asset management industry on one common infrastructure and develop new digital investment models. We are seeing customers in every industry use confidential computing capabilities today, from F5 for mitigating insider threat risk, HashiCorp for managing customer keys, Signal for protecting customer contact details, RBC for correlating partner data with credit card transactions, Fireblocks for secure blockchain-based asset and transaction tracking, and the Australian startup Carbon Asset Solutions, which is using Azure Confidential Ledger to ensure that carbon credit data they collect remains secure and tamper-free, giving buyers confidence.
Thank you, thank you. Most of you probably know that guy. If you don't, give me a call. So what we're talking about at 8 night that Sassy you're really getting to is that some of the offerings that we have, right? If you see that little red thing with the new in there, there's something that talked about at Ignite. So if you see at the top from the top to bottom, the SQL IaaS on confidential VMs, the AVD on confidential VMs that's public preview now, that you can go inside your your environment now and deploy it, see how it works for you in AVD for the confidential VM. I would suggest not to put in production, but it's just in public preview right now. So the Azure Managed CCF there. If you go down to the containers, they're doing big with containers as well. So we have confidential VM worker nodes on AKS and the confidential containers on ACI. And one of our new offerings for, I would say, VM wise, is the DCA and ECA on SCV, SNMP VMs. And those are the rest of the VMs that we have as well, with the DCSV, DCSV3, DCD-SV3, and then the NCC NVIDIA VMs. Then once we get in here, this is some things also that we kind of working on. Some of this stuff in progress, some of already GA. Like I say, limit preview and also in progress that you see there in the virtual machine types, or like the DC ESV5, the Intel TDS VM. And then you get on the right-hand side is things that we're doing with search and ads with LinkedIn for clean rooms. Security, we get Azure AD here, going to be part of it here. And then once you get into financial, Azure Treasury in progress. The Microsoft Payments Card environment is in progress. The Bing Private Search with DuckDuckGo there, and also the Bing Ads are also using. So if you look at this on the right-hand side, as we call it, we are eating our own dog food internally as well, and not just trying to feed it to our customers. So one of the things that we kind of talk about, right, is the confidential computing consortium, right? This consortium brings together like hardware vendors, cloud providers, and software developers to accelerate the adoption of TEE. And TEE is the Trusted Execution Environment Technology and Standards as well. So this community focuses on projects like securing data and use and accelerates the adoption of confidential computing through open collaboration. So one thing about this, Microsoft is a founding member and chairs both the governing board and the technical advisory council of this open source community. But it's not just Microsoft that doing this. We are driving this transformation in cloud security. Cloud service providers are rushing to build and lead in this new space as well. So this consortium was first founded by Microsoft and Intel. Also in 2019, that was founded by Microsoft and Intel. And Google announced their confidential computing offerings in 2020. IBM and Alibaba have an offering in the market, and we're partnering with Facebook to help them encrypt sensitive data as well. So this consortium is like a defining cross-industry standards, driving the adoption of confidential computing and partnering open source to accelerate the option. So I would advise some of you just go at confidential C2 that you can see what we going on in the industry with Microsoft, with IBM, with Alibaba, with Facebook, and everybody else that we're working with on this confidential computing consortium. So most of the time we try to put up our, little compete here that's going on here between Azure, Google, AWS, and things of that nature. And if you look down, everything is green on the security side for Microsoft. The products that we leading with AKS serverless, SGX, we're leading with SGX enclaves for the apps and things of that nature, with thought leadership and things in that nature. So when you get in here and then you go to the right on some of our competitive partners with Google and AWS, they are doing some confidential things as well. But Microsoft is kind of leading that edge on that confidential compute. And then when we get into a lot of things, right? These are some of the use cases that's been working on in retail, financial services, and healthcare. And what I like to get into most, and when you get into the healthcare part of everything, right? So if you see here, it's like disease diagnostic, insurance fraud prevention. I know insurance fraud is huge in Florida. So drug development, contact tracing, records and evidence management, and once again, insurance fraud, waste, and abuse prevention. So confidential computing is some great help use cases in the retail, the financial services, and healthcare. And then when you get into that financial services, guy, everyone have a bank, right? Everyone is using probably some type of money, some type of currency, I would say. So you get into anti-money laundering, digital currencies, secure payment process, including credit card and bank transaction. And I'm gonna tell you that when I was on that team for January to June, it was so many things that I can't really talk about, but it's so many things in the financial space that confidential computing will happen on. And what Satya mentioned before, some of these companies that are working, if you see here in this box here, edgeless system. So this was one of the customers that I working with, like hand in hand when I was on that team. They were a customer, I think, out of the UK. So don't hold me on that, but I think it was out of UK, to be honest with you. And then Junior is a customer that I'm working with as well, and also the other one not up here, but yeah, the RBC is one of the companies that I'm working with as well. So when you get into some of the customer success stories, right? If I'm gonna get into this part that have the quotations here. It's from Beekeeper AI, right? We have a few things going on with them as well in the EDU side. So the platform here, someone that Michael Blum said here there at Beekeeper AI, the platform will provide a zero trust environment to protect both the intellectual property of an algorithm and the privacy of healthcare data, using Fortanet's Enclave Manager for orchestration of Intel's SGX secure enclaves on Azure Confidential Computing Infrastructure with AKS and CDHI's proprietary Beekeeper AI data access, transformation, and orchestration workflows. The platform reduced the time and cost of developing clinical algorithm. All that saying is use Azure Confidential Computing. Use Azure Confidential Computing. Here, this is Signal. Many of you probably seen Signal on your phone. So this something that that Jim O'Leary talked about here in the vice president. And Signal, if you haven't used Signal, it is a free open source private messaging application designed to protect the privacy of messages and user data. So the nonprofit organization had employed Microsoft Azure Confidential Computing as one of its cloud solutions using secure enclave to host back-end services. So this one of the things that Jim O'Leary said. He said Signal developed open source technology for end-to-end encrypted communication like messaging and calling to meet the security and privacy expectation of millions of people every day. They utilize Azure Confidential Computing to provide scalable, secure environment for our services. Signal puts user first, and Azure help us stay at the forefront of data protection with confidential computing. And it's just some more of the customer quotes here. Like I said, I used to do some work as well on the team with RBC and things in that nature. And I had some people close to me doing work as well with BMW. So there's a lot of stuff going on with Azure Confidential Computing on the back end. It is one of the reasons that I want to bring it to the EDU customers, because they able to use this service as well in their environment.
Hey, Reggie, this has been a while. I'm thinking about some of the things that can happen right now, right? So there are already confidential compute virtual machine SKUs that customers can deploy right now to run workloads
Yes.
that they would like to have running on confidential compute hardware.
Mhm.
And Azure Virtual Desktop is a great example. So you rattle off the VD. Maybe some of
Yep.
the customers are not super familiar with what that is. That's a VDI, first-party VDI solution. It's got a whole lot of transport layer security, a lot of really cool stuff. That means that we as architects use it a lot with customers' secure research enclaves. And if you're already going through the effort of creating a secure research enclave with all kinds of network controls, all kinds of screen capture protection to prevent exfiltration, et cetera, it's one of those things you look at and go, well, how much should I be trusting my cloud provider? Wouldn't it be cool if I could run this same workload that I put all this effort into on a secure compute platform? That would mean that I don't have to trust my cloud provider. That even if my cloud provider has some kind of a insider threat that all their mitigating controls don't combat, somehow that gets through, that my data that I am on the hook for protecting is safe while it's being computed. And that's
Mhm.
one of the cool things about this is it sounds like maybe this is a whole thing you have to opt into. And yeah, there are partner solutions like Beekeeper AI, which I'm working with a couple academic medical centers with, that are adoption frameworks and kind of shift the business process in a certain direction. But there are things that customers can do today to take advantage of this. And the shocking thing that I was honestly shocked about is the cost. It's really not different than any other D series virtual machine. It really doesn't look like there's much of a tax. If you want to argue, it might be 5%, maybe somewhere in there. So the point is, listen to what Reggie's saying, right, about all the cool scenarios, right? And then what Reggie keeps reinforcing is, if you got a spare minute, play with this stuff. You might be shocked
Mhm.
at how easy and approachable it is, particularly if you're running workloads on VMs. And then, of course, this is going to make its way into all kinds of partner solutions and Microsoft first-party PaaS solutions as well.
Exactly. Thank you, sir. Thank you so much, there, man. Well, I like how you put it together there. Because it's a lot of things. It's stuff in preview now for, like you said, for AVD and things of that nature. So, um, this right here, like some numbers. Everybody loves numbers, right? When you get into stuff, when you're talking about confidential computing TAM, which is your total addressable market. So for confidential computing, it's likely to grow at least 26 times over the next 5 years in the best case scenario, due to some of the growing enterprise awareness of confidential computing. When I say growing enterprise awareness, that's me as myself, as in December 2021, I didn't know anything about confidential computing until I jumped on the team that we call the Quest program, that internally we can go and see how things are made. And I was like, Azure confidential computing, where did this come from? When did this started? To the point that most of our leaders saying why people don't know anything about it. So I took it upon myself and say, I need to spread the word about confidential computing. Because if you're going ahead and get in this market early, you know what I'm saying, it's a lot of stuff that you can kind of like, behold within your environment and know some things that you can share with other EDU and help them, build this environment like they should build it for the near future. So the confidential computing hardware and software markets are posed for like exponential growth, backed by like expanding regulations, demand for comprehensive security postures, and like appetite for new revenue generators. And it's so funny because when I'm working on this team, I say, hey, why we can't put this in the security posture in Azure that would kind of grow your score and tell you that, okay, now your score is, instead of 75, once you start adding in this confidential computing market, then now your score can go up to like, 85, 90, and you work on a few things behind that to get that secure posture up the way you're supposed to get it to. So that's probably going to be something in the near future that's going to be happening on that the Azure portal there. So also some of the multi-party computing and security specific use cases across industries would be the biggest growth drivers for the technology. Everybody always have this future way things should look. Sometimes it get there, sometimes it don't. But it's just the point of just knowing what you're doing within your environment, knowing the security around a virtual machine that can help you, save these bad hackers, just put them on the back burner because you see things that are happening, or you preventing things before they happen. That's how I look at a lot of things. A prevention, right? Prevention is better than a detection, because once you detect it, it's already there. So that's how I look at it when you're talking about things in confidential computing. So technology first enterprises within regulated industries such as, like I talked about before, banking, financial services, insurance, healthcare, life sciences, they're expected to drive the growth acceleration as well. Probably be like 60% of the market. And large technology markets in North America and APAC, constitute like the lion's share of the market, followed by highly regulated markets in Europe. What I said is it is right. Most of the time, and I have since I've been on that team, it's so much things going on in Europe. I be thinking like, why US is not pushing this as well, right? But Europe, I would say their government is pushing like confidential computing. So that's one thing that I saw with my own two eyes. Like they pushing confidential computing in Europe. And some of the vertical use case that we have here. So Azure Confidential Computing is part of the Microsoft Cloud for Sovereignty, part of the landing zone for the sovereignty Microsoft Cloud here, and in which customers can use to manage security policies designed to encrypt and protect data, govern the hybrid environments, and simplify sovereignty deployment through sovereign landing zone. So this is one of the things here that they were able to add to the Microsoft Cloud for Sovereignty. If you haven't read that whole article about this Microsoft Cloud for Sovereignty, I suggest you go and do that and see how this can help. Probably in your environment or not, but it's good to have that knowledge just in case. So we get into some of the, I would say some of the VM offerings that we have. So Azure DC SV2 and the SV3 Enclave VMs, they are based on Intel Coffee Lake and isolate processors. Azure DC ASV5 and the ECAS V5 confidential VM are based on the AMD EYPC processors. So whether you like Intel or AMD, they have them both for Azure confidential computing. So the confidential VM deployment are simple and easy. So there's no need to redesign workloads or rebuild apps or change your source code. Some of these things can be like a lift and shift type model. And some things, if you want to get very, very technical, then yeah, you're going to have to do some changing in your source code. You might have to rebuild your app, but it just depends. So the runtime performance is nearly identical. So I have some links to the benchmark there. And initial VM boot time may be longer with full disk encryption setting on. You can understand that, right? If you put more things in there to try to encrypt, it's going to take a little longer to boot up. But I don't think it's going to be in like the high, 10% and things of that nature. So if it does, you can get back with us, and then we can talk about what the issues that going on behind that that boot up. And also, they deployed on server clusters dedicated to running confidential VMs only. So in Azure, we have a high bar when it comes to confidential computing, right? So your hardware root of trust. So what it does is ensure data is protected and anchored into the silicon. Trust is rooted to the hardware manufacturer. So even the Microsoft operators cannot modify the hardware configurations. So then you get into your remote attestation for customers to directly verify the integrity of the environment. Customers can verify that both the hardware and software on which their workloads run are approved versions and secured before allowing them to access the data. The trusted launch consists of the features that ensures virtual machines boot with authorized software and that user remote attestation so that customer can verify. So it's available for all VMs, including confidential VMs, bringing secure boot and VTPMs to add defense against rootkits, bootkits, and malicious firmware. And then your memory isolation encryption to ensure data is protected while processing. So Azure offers memory isolation by VM, container, or application to meet the various needs of customers, and hardware-based encryption to prevent unauthorized viewing of data, even with physical access in the data center. And then we get to the security key management. So this to ensure that keys are stay encrypted during their life cycle and released only to authorized code.
So Reggie,
So
I love this because it's an extra layer of protection, right? So if you think about the Microsoft, we document how in Azure Cloud we dispose of hardware, right? And we have practices that are third-party attested to comply with very stringent standards. But how cool is it to have an option that can help insulate, even if somehow those practices weren't met, or there was some kind of new attack angle, against the hardware. And again, we're talking about very, very low level, very, very intentional potential dedicated attacks where somebody's coming in and trying to grab a DIM out of a server and then read the data. That's pretty powerful to say, hey, look, obviously my cloud provider has all kinds of attestations that they're going to do what's right to protect this, my data as it sits on their hardware, obviously shredding disks, encrypted disks, but even scenarios where somebody breaks into a facility, grabs a DIM out of a server and tries to read it on a rig, that's pretty powerful, right? And so to have that level of layers to your onion for what is essentially a minimal trade-off in cost or performance, it's just one of those nice things to have, particularly for the high security compliance areas.
Absolutely, absolutely. So me and you probably won't have to worry about like a payment fraud detection, but this one of the, I would say, secure multi-party computation example, right? So here you have multiple banks share data with each other without exposing personal data or of their customers. So this is just like we are saying about the third party that you don't have to trust. So this just say this like EDU 1, 2, 3, 4, 5, right? So this you can kind of put yourself in the position about protecting yourself from each other when you kind of communicate them with them, right? So these banks run agreed upon analytics on combined sensitive data sets. So the analytics of the aggregated data set can be detect the movement of money by one user between multiple banks without the banks accessing each other's data. So through confidential computing, these financial institutions can increase fraud detection rates, address money laundering scenarios, reduce false positives, and continue learning from larger data sets, right? So when I look at this right here, this more is telling mean that instead of me worrying about what's going on the back end, I'm worrying about how can I get this money across to all the other banks, and then I have confidential computing on the back end, keeping the wrong people out, and also sometimes keeping the right people out, because you never know what people can do with that data as well when they decide, oh, I'm mad, I want to go to another company, and then now I'm taking all this stuff that I know from this company to the next company. So that's how they can work as well. So your outcomes, you get increased detection rates, reduce false positive, and iterative learnings here.
So I'd say, like, think about how this might apply to research, right? So in this context, it's financial for profit, right? And the value to each of the banks is their proprietary customer data, yet they want to aggregate behaviors so that their ML AI model has a higher detection rate to prevent fraud. If we change this around to a medical research scenario, think about the pain some of you on the call deal with collaborating with other institutions where data use agreements have to go in, customer PHI and privacy agreements have to go in. There's a lot of responsibility that each of your collaborators takes on because the way we're doing it today, they can see the data. If we shift to a model like this, you can see how you have a scenario in which you could say, okay, I have my agreements with my patients. They've signed over patient patient data rights to me. They don't also have to agree for the 4 other institutions that are collaborating in this study, because those other 4 institutions cannot see the data. They can only see the aggregated outcome of the ML AI algorithm that is trying to detect something like incidences of correlations for disease X or Y or Z. And so I think it's really, really powerful to think about this as we, use it in the context that are EDU specific, things like medical research.
Mm-hmm. Absolutely, sir. So this another like side that they're working on here. So if you see here at the top, so you got a secure release of keys and secrets enclave to enclave. On the left hand side as well, you have your preserve the end-to-end confidentiality of multiple data sources. Over here in your AKA, you have your stored ML trained models confidentiality, your track of compliance ML predictions, and also your attestation and execution in a confidential environment. So this right here is just more of your user coming in your public API. Then your public API going to hit your SQL database. Then this right here going to store the ML trained models confidentially. And then you're going to send it to your data validation within your AKS and things in that nature. And then from there, it's gonna bring yours here to the SQL database AE with SE here, which is your always encrypted. So we also doing always encrypted with confidential VMs as well, and also your AKS as you see here. And then another thing about confidential ledger that I'm kind of going to mention in a few slides here. And it's just a credit card tokenization. We're not going to get into that because it really don't meet the need of, well, it could meet the need of your HR department in EDU as well, things in that nature. And also when you're doing, I would say, classes, or people signing up for classes and things of that nature. So it could help in the EDU environment as well. So I'm not going to say it wouldn't help, but it could help as well with the credit card tokenization. So here in the scope, you have the memory generation of the unique token for each credit card that gives a different output, even when the input is the same value. And the token is stored until processed by the payment gateway. And then it also would meet that PCI compliance there that we have. So here is something that's, if you look at this part here, is like confidential computing spectrum. It's like the ease of use and then the security control here. So once I bring these things over, you'll see where you can use things at, right? So the easy button here is like existing apps, sometimes no app source. You want confidential computing, please turn it on in the cloud. Just like the easy button part of it. You have minimal effort across the board. Got the people and the infrastructure and things in that nature. The hardware is isolation. You don't trust your CSP. Guest and OS and guest admin is trusted. So that's why we use, like, you can use confidential VM or trusted launch or confidential services, right? But when you get into like a balance thing here with confidential containers, confidential services, your existing apps open to minor changes. When we talked about, easy button, no changes at all, but you open to minor changes to get that balance. You would do some work with confidential computing, hardware isolation. You still don't trust your CSP or your guest admin now. in additional code is also trusted. But when you get into that most control section of it, you have your enclaves and confidential servers that you can use with it. You have the customer apps. You want complete control. You don't trust, your hardware is still isolated. You don't trust the CSP. You don't trust the VM admin or the VM OS. So these things right here are going to cause for you to do more with confidential computing. So also we on the back end, we work with a lot of ISV partners, right? So you're looking for like new refactor apps and things of that nature. So it's a create a trusted portion of your app to run inside the enclave or the TEE. This part of the open source, so you can use the OES SDKs, the Intel SGX SDKs, or the Edgeless RT. And one of the partners that I'm working with, to be honest with you, was Edgeless System that we talked about before. And then you get that most control over everything that's going on with your new refactor app. So with the lift and shift in certain apps, like you get existing app container to run confidentially with no minimum changes, so you don't have to worry about doing a lot of things. Those are some of the ISV partners in open source with Mystica's, Oaklum, and also Edgeless and Graphene. And here you see that your code and data gonna be in your container SG apps, and then also gonna be in the hardware for your CPU there. And then you see here that general available hardware enclaves with Intel XGX. So I just trust my app code in the chip. That's it. You trust your app code in the chip. And that's the secure enclaves. It's just breaking down between the different protection that you have. So here you got a full VM level protection. It's like a lift and shift existing app. You deploy to a new VM size, which would be like a DC series or EC series, right? So anything you see like EC, DC, that C stand for confidential. So when you try to deploy things and just look at it, see how everything works on your end. If you're just doing like a dummy deploy, just know that DC, EC, the C inside of it stand for confidential. So you have a general purpose hardware and availability. It's isolated from the cloud provider, which is Azure would be then. This is your easy button part of it. So if you look to the right of it, VMs today, your workload, code, and data. Like I said, this is not taking the place right now of VMs. This is just the evolution of confidential VMs. So once you get down here, the VMs are all over here, right? So when you get in a hardware confidential VM, you have your workloads, code, and data locked down. Everything here is locked down here. And then once you get in your AMD, SMB, SMP, it's locked down. So Microsoft cannot touch my stuff in my VM. If I purchase my VM, nobody should be able to touch it. If I purchase like building like a house, it's like if I got my own house, I'm built my own house, even though my builder built this house, this mine now, I don't want you in my house. You know what I'm saying? Unless I give you control of that, unless I tell you this is where I want you at. So here, you knock out the or the hypervisor, the data center, the boot kits and the services, and only person that have trust here is the VMOS and the VM admin. And that's in limited preview now. And like I was talking about for the AE part of it, so this is Azure SQL database, right? It's always encrypted, which is the AE with secure enclave. So we kind of, I would say Microsoft, I went here in 2015, so I'm not going to say I did it. So Microsoft started this journey towards the confidential computing vision in 2015. And then they released the initial version of Always Encrypted. So Always Encrypted, its original version was a client-side encryption technology, right? The data gets encrypted on the client side within the client driver before being stored in the database. The data is never decrypted inside the database. This provides strong but computation on protected data. It restricted to just one operation. Equality comparison, which is supported via deterministic encryption. So now we're expanding this capability with technology called secure enclave. Now, when processing that SQL queries, the database engine delegates computations on encrypted data to a secure enclave. So that enclave decrypts the data and performs computation on plain text. And this can be only done safely because the enclave is like a black box to the container database engine process in the OS. So the DBAs or the machine admins can see the data inside the enclaves. So by leveraging these secure enclaves, Azure Encrypted can support rich confidential queries including pattern matching, range comparisons, sorting, and more. It also enables places like cryptographic operations such as encrypting existing data or rotating those keys. So here you'll see here we have Microsoft Azure Attestation and also your Azure Key Vault Managed HSM. So for the AKV, you don't need to provision, configure, patch, and maintain those HSMs or the key management software. So each HSM pool consists of multiple HSM partitions that span at least 2 availability zones. In this case, a hardware failure, member partition will be automatically migrated to healthy nodes. So you don't have to worry about like any kind of hardware failures. It automatically migrate to a healthy node. So it's something that you don't have to worry about, which kind of take that headache off you and things in that nature. So each managed HSM instance is dedicated to a single customer. So every HSM pool uses a separate customer specific security domain that cryptographically isolate each customer's HSM pool. So it's built and run on ACC, your Azure Confidential Computing, Intel SGX, DC SV2 VMs. And this another thing here, if you see here, it's like Azure Confidential Ledger. This is something that's been out for probably about a few months, maybe about 6 months now. So it is, I think it is GA now. So it's like a tamper-proof audit log for storing sensitive data blobs and records in a way that fully confidential, immutable, and verifiable. So users can always audit and validate this authenticity of all ledger data. So the future is confidential. The future is confidential. So like I said before, instead of calling us Azure Cloud, you're going to be Azure Confidential Cloud. So you're probably the first to know about this confidential computing here. But there are always opportunities and challenges, right? I mean, that's everywhere. The opportunities of customer are among the first to achieve the highest security posture and setting the pace of the inevitable evolution of the industry. Like I talked about before, the evolution of the industry. So it is not taking the place of it. It's just evolving the offering that we have so that your cloud can be confidential. So you can achieve competitive advantages on use cases that were previously hard and impossible to do, such as on-prem to cloud for sensitive workloads, the multi-party data analysis that I showed you, the secure management, confidential databases, and analytics, and much more. So you get access to engineering group directly, ensuring a strong workload fit story into Azure. So that's one thing that we can kind of do for our product group. We go straight to them. Hey, what's coming up next? How everything doing? You know, what we need to tell the customer. The customer had this question. We take it straight to the PGs because those are the people that kind of like making this sauce in the kitchen to make sure that the customer is successful as well. So some of the challenges, confidential computing is still relatively new and awareness is lacking. This is the reason why I wanted to go with my presentation. Your data is protected, Azure Confidential Computing. Because the more you talk about it, the more people find out about it, the more people tell other people. You know, it's about like a good movie. You're not going to keep the good movie to yourself. Most of the time, you're going to tell somebody, then that somebody going to tell 5 people, that 5 people going to tell 25 people. Now everybody knows what's going on. So the capacity is not globally available yet, though Azure is rapidly deploying regions that demand qualified region. As in, I think within the EDU, we do have enough things on the West Coast and some databases as well. Well, not databases, data centers on the East. I think in East US 2 and West US 2 that we have it. I think they have some in Central. So it should be good on the EDU side. But if there's a capacity issue, then we'll go to the capacity team or through the Azure Confidential Computing team, asking when that capacity is coming in that area or in that the Azure region. And there's no public regulations yet, but expected to catch up as technical advances outspace governance guidance. And here are just some of the links for your Azure Confidential Computing, the ACC documentation, some blogs, and also some ACC stories. Thank you for having me. Have a great day. Over to you, Steve.
Sure. Thanks a lot, Reggie. If there's any other questions, or actually, if there's any questions and people want to come off mute, just raise your hand. I'll take you off mute. If not, I think Caden had put the link to the questionnaire that was pinned in there. So please do take a moment to fill out the survey. And on that note, we'll bid everybody adieu. And Reggie and Manuel, thank you very much. It was awesome listening to you guys talk.
Thank you all. Be safe. Stay healthy.
Take care.
Thank you,
Bye-bye.
everybody.